This experiment tests for the expected globe-Earth curvature over 213.47 miles of Lake Erie. The start point is Nickel Beach in Huron, Ohio, and the end point is near LaSalle Park in Buffalo, New York. We will not be using the Nikon P900 or other optics, and so will not be dealing with the obvious resulting distortion due to refraction over water, such as here and here. For this experiment, we will be using the InvenSense MPU 6050 inertial measurement unit. Part number is BJY-61. Software is Mini-IMU. The unit can operate through the TTL to USB converter, but we will use the provided Bluetooth connection to the PC. Unit will be powered through the USB port. BJY-61 module main feature: acceleration 3-axis, angular velocity 3-axis, angle 3-axis calculated with embedded Kalman filter. Product code at Amazon is BWT61 Bluetooth MPU 6050 module angle output 6-axis accelerometer gyroscope. Their price is $15.90.
We will start with the accelerometer. It measures acceleration by measuring change in capacitance. Its microstructure looks something like this. It has a mass attached to a spring, which is confined to move along one direction and fixed outer plates. So when an acceleration in the particular direction will be applied, the mass will move and the capacitance between the plates and the mass will change. This change in capacitance will be measured, processed, and it will correspond to a particular acceleration value. Next is the gyroscope, which measures angular rate using the Coriolis effect. When a mass is moving in a particular direction with a particular velocity, and when an external angular rate will be applied, as shown with the green arrow, a force will occur, as shown with the blue arrow, which will cause perpendicular displacement of the mass. So, similar to the accelerometer, this displacement will cause change in capacitance, which will be measured, processed, and it will correspond to a particular angular rate. The microstructure of the gyroscope looks something like this: a mass that is constantly moving or oscillating, and when an external angular rate will be applied, a flexible part of the mass would move and make the perpendicular displacement.
High precision pitch, roll, yaw, angle output. Embedded Kalman filter for high precision angle output. 3-axis accelerometer, 3-axis angular velocity, 3-axis angle measurement. Bluetooth serial port wireless communication can also connect with cable, providing PC software, app, and 51 STM32 Arduino sample code. BJY-61 gyroscope is a good solution for angle measuring, acceleration measurement, and angular velocity measurement. It packs a 3-axis gyro and a 3-axis accelerometer. Kalman fusion filter combines the gyro and accelerometer to get high precision angle measurement. It can be used for 4-axis flight control, self-balancing robot, angle measurement, and depth measurement, and so on. The module can get accurate attitude in a dynamic environment. Attitude measurement precision is 0.05 degrees, high stability. With advanced digital filtering technology to reduce the measurement noise and improve measurement accuracy. Bluetooth wireless serial port communication, and also can connect to other equipment with line. Note, angle of z-axis will have accumulated error because there is no magnetic field correction. This unit does not have a magnetometer and is not influenced by the Earth's magnetic field. Here is the setup from the car's 12-volt output to a sine wave power supply. Here's the laptop with the app loaded, and here's the MPU 6050 module mounted on a board which allows for leveling. And this is the TTL to USB converter. As stated, we will be using the Bluetooth to communicate with the PC. The USB connector is to power the unit. And this shows the unit responding to the motion of the board that it is mounted to. The formula for ball earth drop is miles squared times 8 inches. 213.47 miles squared times 8 inches equals 5.77 miles expected ball earth drop. What follows is a portion of a prior video which talks about how to calculate the expected pitch change when flying over the ball earth. The same formula works whether you are traveling by air or by land. Gyroscopes maintain rigidity in space. That is how they provide a service to air flight. They inform the pilot what is level flight and inform when the plane has changed pitch. If a flight path is over a curved earth, the gyroscope, while maintaining its rigidity in space, will inform the pilot that the plane has changed pitch. We are told the circumference of the alleged globe is 24,901 miles. The formula for the cumulative change in pitch of an aircraft flying over a globe Earth is miles times 360 divided by 24,901, which equals the pitch, which equals the total angle change. Miles times 0.014457251 equals pitch equals total angle change. The product of 213.47 miles times 360 degrees divided by 24,901 miles equals 3.086 degrees. This is the expected ball earth pitch change when traveling 213.47 miles over Lake Erie. The test starts at Nickel Plate Beach in Huron, Ohio. This is the first test of the experiment. The board has been leveled up with the 4 bolts at the corner of the board, and I am using the Bubble Level Pro Android app. This is the screen of the Mini IMU PC app. We are concerned with the angle X and angle Y, pitch and roll, those 2 numbers in degrees. Here is the second test, where I again attempted to get a precise level for the board. And here again is the angle X and Y output measured and calculated by the unit. And here is some pictures from I-90 east of Erie, Pennsylvania, on the way to Buffalo, New York, filmed by another traveler. You can see the horizon formed by Lake Erie rise to eye level. As I traveled to Buffalo, New York, I was reminded that it was the hometown of the great flat earth pioneer, Alex Gleason, who gave us the Gleason azimuthal equidistant map, which has been such a godsend and a wonderful tool to introduce the flat earth concept to a multitude of people. He also is the author of the flat earth classic, Is the Bible from Heaven? Is the Earth a Globe? Alex Gleason, 1893. Within the book, engineer Alex Gleason documents his own flat earth experiments conducted in the Buffalo, New York area. Here's the first test in Buffalo. Again, note the X and Y angle outputs. Here's the second test in Buffalo. X and Y outputs. And here's the third test in Buffalo. X and Y angle outputs. And by the way, those are not clouds in the sky. The sky was pelted with chemtrails all day. Made a very gloomy appearance, and I do apologize for that. The bridge we are looking at connects the U.S. to Canada. Late in the day, we're back here in Ohio, conducting another test at Nickel Plate Beach. Note the X and Y angle output. And here's the summary of the test. This is the expected ball-earth pitch change when traveling 213.47 miles over Lake Erie. I should note that the unit stayed on during the entire test. There was no power cycle of the unit or of the PC or restart or recalibration of any device. The Android app used to balance the board was not recalibrated. It used factory settings throughout the test. My name is Rick Zimmerman. My channel is Seventh Day Truth Seeker. Thank you for watching.